Okay, well, okay, good morning. So today is March the 15th, and this is a CS 116 class. And so today we're gonna talk about another properties of object-oriented programming. And we spoke about the encapsulation, which so far talk about defining class object, have a different kind of interfaces. And then we have class attribute, class member functions. And today we're going to talk about the second property of object-oriented programming, which is inheritance. So just a reminder, and so next week, yeah, I'm sure you guys don't need me remind on that one. Next week is a spring break, and so there is no class next week. However, so I have the lab is due on Monday. So you still need to finish in that sense. Don't send me email say, "Oh, Monday is a holiday. Why we still have to do it?" Well, I can make the sense due on Friday as well, this Friday, so you won't have that kind of argument. In the past, one student said that to me. I just said, "Guys, give me a break," right? So you're not supposed to just do on the last day. So don't send me email say, well, Monday is a holiday, so why the lab is due on 22nd, so you can finish everything before that. Okay. So next week we don't have a class. Okay, it's a spring break. And so today I'm gonna talk about the inheritance. And so part of the inheritance, and I believe this things are posted in our Canvas already, and it's more of how can you use something you already defined. So in this class, we defined a class object called a person. Okay, so a person has a name, whether it's a first name, last name, and have a birthday. So you as a student is a person. You have a first name, last name, and birthday. I am as an instructor. It's also a person. I have first name, last name, birthday. But as an instructor, I also have all the different courses I teach. You as a student is a different course you're taking. Or as an instructor, I also have they pay me. I have a salary. You as a student, instead of pay you, you have to pay them, right? So you keep track of different kind of properties. But all of the things has one thing in common. It's we are all person. So this class object we defined in the past, a person with a first name, last name, and the birthday, well, certainly can be utilized, reused for instructor or for you as a student. So that is what we call inheritance. So here is another example of inheritance. So if you're looking down further to the lowest level, right, SUV or sedan is a car. Yeah, it is a car. But car is also a vehicle. Motorcycle is a vehicle. Truck is a vehicle. So this one, if you define a common denominator for vehicle, and then that sense can be used for motorcycle, for car, for truck. And then sedan and the SUV is a part of the car. Then if you have something is so unique about the car, and you define class object for the car, and then those two can using car object. So to using it is what we call inheritance. Okay. So it is more of let's get some terminology, and defined. So we have one called base class and derived class. So this is a base class. Car is derived from the base class called vehicle. So car is a derived class. And here's the base class. Base class is some other class object derived from you. Okay. So that's what they mean by base and derived. So every car is a vehicle. Well, here's a car. Well, every car, that means if this is a part of the car, it's a vehicle. Every truck is a vehicle. Every sedan is a car, it's also a vehicle. Every sedan is not a motorcycle because they're not part of that class. Okay, it's not a truck. Okay, so that is what they call is a inheritance relationship. It's a relationship. Okay, and so that is the example I just went through, right? So so SUV is a car, so car is a vehicle. That is a relationship definition. And then so this one to talk about inheritance can go through many different levels as well. And so there is no limit how many chain of inheritance. You can also inherit a multiple things. For example, you have a car, right? And then you can also maybe have another one, just called economy car or something like that. And then sedan could be part of the economy car and also can be part of economy, or compact car or something, right? So it can belong to multiple classes as well as part of inheritance. And so some of the areas we have already using inheritance already. And in C++, you may have already used this. And so you have is string that's using for string data type, if string, and this all part of this base class called is string, and this is Apple string, right? So you've been using that differently. So what happened is you just reusing the input that you want to use, right? And without worry about and redefining the definitions. Okay, so in the book, they also has one they call the quiz, right? So they say, okay, I have a different kind of quiz. I have a different in quiz I have different kind of questions. Some of the questions is fill-in questions. Some of them is choice questions. Where choice question can be multiple choice or can be true or false, right? And so you define that kind of inheritance. So that you can learn from it, right? So you can reuse the class object. And for example, in this particular example, you say, okay, I have a class, right? I have a question, right? So we all know how to do that right now. And part of this question class is called interfaces. I have a text and answer. So that is the question, what is your question? And I have an answer associated with it. And then I have default constructors. Then I have some of the modulators and the accessors. I can set the text, right? And I can set the answers. I can check the answers, check the display everything. So that is a standard questions for this. So here is your questions. So regardless which one you use, here and this one is the same. So it's applicable to your fill-in questions, to your choice question, to numeric, it's the same. So that is what we call this. This now is a base class. So now I say, gosh, I want to do multiple choice. Multiple choice, it use all of this, right? Use all of this, but maybe have something a little bit more, right? And so here is, same thing, and now they add documentations. So then, as I mentioned in this class, you have to do this kind of documentations for every single member functions, right? And then this one, now you're defining those outside, you don't define inside. And so you don't, once you define inside, it's called inline declarations, but you define outside. The reason for that is because now everything is part of the object-oriented programming is a reusability, and share your code or your library with somebody else. And when you share it, you have to give them the .h file, which is the definition. But you don't want to give them the code, right? And because that is your intellectual properties. And you just give them a DLL, the library object file, and then they can link to it, okay? I am the only one allowed in this class, okay? If I embed it into the definition, just because I want to save time, I'm allowed to do it. You are not, okay, for your lab, okay? So don't do that one. And so this is just a simple questions, right? And ask for that. So now we're getting into, here they talk about guitar. I don't know why the student went to guitar now. So here they talk about guitar, okay, fine. And so that the guitar is derived from instrument. So guitar is an instrument, and acoustic guitar is derived from guitar. Electric guitar is derived from guitar. So now they're gonna say, how do I define the similar items for it, okay? So I'm gonna give you some examples on that. Okay, now we're back to the questions. So now you say, okay, in the questions early on, right, we have this, a question. Here is a different type of questions, okay? And we define the question already. So the question has text and answers, and here is all the function for the questions. And, and then you say, oh gosh, you know, a choice question is identical, it's the same. So in this particular, let me pick one that actually has a little bit more. Oh yeah, use this one. A choice question is a question, but then you have a selection of questions, right? So you have, you know, a vector of choices, all the choices you have, but it follow the same principles of that, right? And so that one you use if you don't use if you want to keep track of the choices. But then you can also say, well, I don't want to do that. Actually, I want to keep track of, you know, and the different choices as well. And so, and let me see here. And so then you do this, you go to the next one, right? So you say, okay, here is the question, right? That's the one we've seen before. Excuse me. So now you say, I have a choice question, and I want to use everything defined in the question itself. So then you have, so now we call this inheritance. So you're using a single quote. Single quote means is, I mean, single colon. Single colon means, single colon means, means inheritance. I want to inherit this question here. So now I want to do inheritance of a public. So most of the inheritance is done with a public. And they also have another one called protected. And as we know, you also have a private. So you never use a private. If it's a private, that means nothing you can do, you know, and because everything is hidden. So typically in the book, in many places, you probably just see, you know, the and then you have your own section, choice question, right? Your default constructors. Then you add some more functions that only pertaining to this class object. And so that means everything here, okay, everything defined in questions now is available inside the choice question. So it's similar like you copy this whole things over to here and copy this to here. It's the same. But why you want to do that, right? If you already define this, just like the person, I already tested, I know all those functions, member function works, I just want to use it. So that is what you do. You just inherit the whole things over, right? And so you inherit the whole things over, and then you can just really then define, right? You define the member functions, so you could choice question, right? Which is this, and then you define now those functions. It's the same way as you did it before, double colon. It's the same, and then you use a vector. You push the choice, right? So it's the same thing. You're doing it, and then. So the other thing is and then when you start using it, you can use the things inside of this question. I'm going to show you the code example how this one's being used, right? So pretty much you can define all that, and then other things is I also mentioned, this is the interface. We typically just use the public, okay? And if you don't say anything, by default it's a private. Right? It's the same. But if you do private, that means you cannot really accessing it, and really doesn't do you any good for that. Okay, and so now let me go through some of the examples, and for that, let me cover this. Then I'll go through it. Overriding member functions. Okay, so what does that mean? It means it's what happened, and so let's go back to this guy. So here you have a display, right? You have a display here. Here you also have a display. Two of them are the same. And which one do you use, right? Of course, it depends on your data type. If you're using question as your variable, of course it's using this. But if I use a choice question for my variable, I have two. Which one do I use, right? By default, it uses the one that belongs to itself. You will not use this. Now, inside the display, you can call this one, but it will use the one by itself. And that is what we call overloading. So you overload it, and this for instead of using the base class, you're using your own, right? If you don't have this one defined, if this one is not defined, you will just use this. Okay. And so then, since we have two displays, and now you're doing this, you say, gosh, I call it display. Well, it doesn't know which one you're using. You also have one for you, for yourself. But I really want to call this display from the question display function, right? Because I want to do, maybe I have a display in the questions, print out the questions, and here I want to do my own. I want to add some more features for choice question, how I display it. So how do you call this one? How do you call this one? Anybody want to take a wild guess? Think about scope. How do I call display part of the questions? Anybody have a guess?
Display.
Well, if I just use the display, it doesn't know which one, right? So you're using this questions : right? Display. Now I say, oh, you're referring to this display. So that's a scope, right? So now inside the choice question, you have a display, and then because this display is a part of the question, and so you can call it. The reason is you inherited from it. Right, you inherited the things from it, and so that's you inherit the question from here. So you inherit it, so you can access anything you want from here, okay? Because you inherit it, and So to call, a function that is part of your inherited class, right? You're just using the scope like this to call the other functions, especially if you have a same name. If you don't have the same name, it will resolve it. But because it's the same function name, it doesn't know which one. So you have to explicitly say which one you're calling, right? And so then, here is the member function for the choice. You add some more things to it, right? You can, here display, say, okay, I want to call the display for the part of the question, but then I also want to print out my own display because for me, I have a different set of choices. So now you can just say, as you can see, you can reuse the other base class member function you already wrote, right? So this is where reusability comes in. You can using it, right? So now you can do it. So now inside here is your program, right? And so question, right? So it's a question, which is a base class Q1. Then you can set the text, right? So who is the inventor of C++? And here is your answer for each one of them. And then you display it, and then you get your answer, and then you check then you also have to check the answer, right? And then you also say, okay, I want to do a choice question. Remember, choice question, right, is derived from a question itself. So part of the choice question, so when you say set the text, okay, and so this one, if you go back to, let me bring the things over side by side so you can see it. And okay, let me do this, okay. And let me do a screenshot so that's way you can. Okay. So now let me go to the other code. And okay. So you go to other, here, I say, okay, it's a choice question. Choice question is here. And you inherit it from from the from the public question. So you inherit it. And then you can say it's, well, here I have a set text. Well, set text is not part of a choice question. I don't have it, but set text is inside here. So you can call that directly, Q2.setText. Q2 is a choice question. Because you inherit it, you are allowed to use everything here in the public section. Okay, you're allowed to use it. So then you can also say, okay, I add a choice. So add a choice is my member function for this choice question data type. And then I just add it and to it, right? So now I can, add the choice is, well, Australia is true, right? And Denmark is true, or whatever the sense it is. And then Q2.display. So Q2.display, so here is Q2 is a choice question. .display. So I have a .display here. You will call this .display. Just remember, in this .display, you also will call, right? Call the base class as well. So you can calling it by explicitly say which one, right? And so now you don't have to rewrite all the questions, class object called set the text, add the answers. You don't have to do that, right? And so if you run the program and that program will say, well, who was the inventor of C++? Your answer is this. Then you say, in which country was the inventor of C++ born? That means where does Strastrup born, right? And inside there, we set the answer, well, Denmark. So if you answer Denmark, that means it's true, right? So then here it is, your answer is 2. That's yep, Denmark, true. That means you got the question correctly, right? So that's how they implemented, a multiple choice questions, right, in the class object. And so now let me go through some examples, other examples, okay? So I have one I call the ship, right? And okay, I have a ship, and the ship usually means like your cruise ship or commercial cargo ship, wherever it is. And I say, okay, it has a name. I have a year built, is a private, and then the member function is a ship, right? So I have constructors, and then I have some member functions I call display info, right? And then I have a display info like this and this, and this is nothing new to any one of you right now. We've done that many times. Then I also say, I want to also define a cruise ship. Well, cruise ship is, if you have a cruise ship, it also has a ship name and the year built, right? And no need for me to rewrite all this. I already wrote it, I already defined it, right? And so I say, okay, now, of course, all this in your program, all this is in a different .h file. So here is in your ship.h file, and this is in your ship.cpp file, okay? And now here, this is in your cruise ship.h file, which will include ship.h, right? You want to separate all this. And this will be in your cruise ship.cpp file, right? You want to separate just like we learned already. So I say, okay, the cruise ship is also ship. So now I do inheritance public ship. But the cruise ship also has one extra characteristic. I said, well, how many passengers can it hold? Okay, I already know the name of the cruise ship we year built. I also want to know how many passengers. So that means you will inherit everything from the ship. In addition, now you have your own number of passengers. And then, of course, I have my constructors here. I have also my display here, right? And so inside each one, right, I also mentioned you need the documentations. So sometimes I don't do documentation just to make it easier for me. I don't write every single documentation example I show you, but you have to do that, okay? Because one student said, well, you didn't do that in your examples. No. I just want to make sure I don't have to do it. You have to, okay? And also, you cannot put everything in the same file. That's the same logic. I can do it. You cannot. Okay. And then here is you define the cruise ship, right? So this one is the same as before. However, you have one new thing here now. So this we know is constructors. So constructors, as we know, constructor is called. And when the things are in scope, right away when it is in scope. So if I call a cruise ship inherits from the ship. Well, ship also, so once I define a variable called cruise ship, and ship is a part of the things I inherit, so that means it is in scope as well. So that means the constructor must be called. So here I have a cruise ship, a constructor. Now I say, oh, I also want you to call the constructor. If you don't say it, you will just call default constructors. But in this case, I want you also pass on the parameters, the value to the base class constructors called ship. So you're using single colon to say, the same thing. Single colon is used for inheritance. You use a single colon, then you say ship, and you pass the parameters from here. So string N is a name, year, Y is year, right? So then after you calling this, so first thing it does is it will call this ship constructor here. So you will go to this one, set the name to name, year built, Y, right? Once you've done that part, it will come back to set its own passenger. So remember I mentioned if you use the same name, right? And to avoid ambiguity, right? You're using this. This means is this object, the one you're referring to. So if you add this, a pointer to it, then everything's fine. So now you have the cruise ship, the constructors. Then display info, as I mentioned earlier, display info also is inside this base class. So base class, I say display info, I'll say, okay, I want to print out the name and I want to print out the year built. But since it's cruise ship, I also want to know the passengers, okay? No need for me to rewrite, the things on the ship. I just call it ship, double colon, display info. So it's called the function belong to here. And then after that, I just add something I did, right? You can also, do this, and instead of this, you can also call directly get name, right? Get year built, because get name is a part of a ship. Get year built is also part of the ship. You can call directly. The reason you can call directly because you inherited, right? You inherited the ship. So if you inherited the ship, everything in here, okay, it's a part of here. Everything here is being it's the same as over here. When you're compiling it, it was just linking everything, right? So you can call that directly. And since I already have this, I said, no need for me to write my own, right? And so you do that. And then you have a cargo capacities, right? And oh no, I'm not cargo. Let's go to the passenger ship. Sorry. And so maximum passengers, right? So I've had maximum passengers. So now I say, okay, beside cruise ship, I have a cargo ship. Well, cargo ship is the same thing, right? So it has a name, year built. Only thing is, well, how heavy is the cargo ship? Is how many tons does the cargo ship can haul, right? And so you have a tonnage, right? And then everything is similar, right? So you did default constructors, and then you call the ship constructors, and then you set everything, and display is the same thing, right? It's the same thing. And then in your main program, you can say ship, right? Lollipop. Lollipop is developed in 1960, was made in 1960. And so then the Disney ship, okay, now I say cruise ship, Disney ship is called Disney Magic, was built in 1998. It can hold 2,713 passengers. Cargo ship, OOCL, actually this is, I don't know, it's still the truth. It was one of the largest cargo ship in the world in terms of how heavy it can do, right? And was built in 2017 and has 210,890 pound tonnage, right? So once I've done that, I can say Lollipop display info, Disney display info, all this, right? And and let's compiling it, right? And so I already compiled earlier, so just let's run it, okay? So once I run it, okay? So then in ship display, I'll say, oh, what did that come from, right? Where did that come from? Well, so it comes from, I did a little debugging, so you know the sequencing. So ship over here, so ship over here, you call Lollipop, okay? And what does a sense does when you first define it? This is in scope. So constructor is getting called. Okay, let's see ship constructors. Okay, that's a ship constructors. I'll give a parameter. So this is getting called right here. And so that this is this one, right? So this one is getting called. And so this one is a set. The value is a set. And so actually I should do this. I should do this. And so you know it's in there. And okay, so let's do that. Then you can see, you know, the things are getting called without you really calling it, right? And so let's. Okay, so you finish building it. Let me exit this guy. Let me run it. Okay. So you go to ship, lollipop, right? So I say, okay. And so default constructor is getting called. And you go to ship, in ship constructors. So this one, in ship constructors. And so then the next time it comes in, I also call cruise ship. Cruise ship is Disney, right? Cruise ship is Disney. And then you go to cruise ship in the Disney. And so actually even better. So you know which one it is. In ship things, let's do this, okay? And let's just print it out so this way we know where it is coming from, okay? And because otherwise, and this is a good way for you to debug your program. And so this way, you know, you if you want, you can add a little cout, or another thing you can do, right? You can do define a global variable called debug, or you can use a command line parameters using argv, argc, and then you can just use if whether it's use a debug or debug, wherever things is at, and then you can just enable all the debug statement, you know. So I'm gonna do that in the future. So this way you know, right? And so then that's another one in cargo. Okay, let's see to this one. So this is N. Okay, so this is what we know where it's coming from. Oh, sorry, did not done that correctly. I'll put that as a string, okay? So I have to do this. And okay, let's do that. Okay, so I think now that's it. Yeah. Okay. Okay, so now it's a little bit more clear. So ship, lollipop, right? And so you say, okay, let's go to lollipop. So you say in ship constructor lollipop. That's this one, right? First one. Then the cruise ship, I say cruise ship Disney. In ship constructor, right? So then you know, it's Disney. So you call the ship constructor first. right? So if you go to cruise ship, here's a cruise ship. So remember, the base class is getting called first. If you don't specify which one to call, you will call the default constructors. But you always call its parent. We also call the parent. So this is a child class. So cruise ship is a child class of the parent ship. So ship is a base class of this derived class cruise ship, right? Ship is a parent, right? So then you can have another one, that's just, for example, if there's one called transportation, ship is a part of transportation, and the cruise ship, the transportation is the grandparents of cruise ship. So you have a multiple inheritance. So once I call the Disney ship, right? And so you call this, so that's the reason you're getting this one. Once you finish that, right? Once you finish it, it will come back to here. So that is the reason you got Disney Magic here, right? So once you finish that one, you move on, right? You move on to cargo ship, right? So cargo ship in ship constructor is the same idea, right? And so then you call the cargo ship, and over here, and you call the constructor for the ship. And once you finish it, you return the control back into this first line of the code. That's what you got here, okay? And so the things I highlighted here is coming from this 3 lines, okay? So once you've done that, you say, okay, I want to do a lollipop display. You display it, right, in that sense, and then you print out your build, right? And then same thing as this, right? So now you can see it's have a default, have an inheritance of the ship, and made it so you can have cruise ship or cargo ship. Any questions so far? Okay, so then let's take a look at this one. And this one is more of the order the things are being called. So we know, so you have constructors, and this is what we call destructors, okay? And put a tilde sign in front of the destructors. Constructor is called when you're in scope, when you're in scope. And destructor is called when you're out of the scope, okay? And so let's see how this whole thing works. Okay, let's just run this program, then we'll go through 9 by 9 to see why it went through certain places. Okay, so here, test, that's the first one, right? And the foo, I call a function called foo. Okay, here's the foo. And I say, okay, C is a CC class, and 5, 4, and R. So what is the CC class? And so you say, okay. And CC class is a part of the C. So here's the C, okay? C is inherited or derived from B, okay? So it's okay, what is class B? Or class B is here. Well, B is derived or inherited from A. So now you can see you have a chain of inheritance now. And so A is the base for B, B is the base for C, C is a child of A of B, and also C is sometimes they say is a grandchild of A because of multiple inheritance. And so this is the B, A is the base, right? And B is derived from A, C is derived from B. So what does that mean? It means is for C, because it derived from B, okay? It can use everything inside of B. So B can use everything, derived from A. So B can use everything from A. Well, by definition, since I can use everything in B from class C, that means C can use everything from A. Well, because I can use everything from B, B can use from A. Of course, C can use everything from A as well. So inheritance is passing down. Okay, it's passed down, and so you can have inheritance, right? And I think last week I talked about friends, and so there's a couple things it's cannot be inherited. One is a constructor, because constructor by itself is only for that class object. And another one is a friends. Remember, I will use a friends function. Friend is you define a function that is not part of this class object, but you just temporarily give you access to the class object. And the friend cannot be inherited. Just like your friend not necessarily is my friend, right? So it's the same thing. So friend cannot be inherited, okay? So now, so I have, this program. So now I go to foo, right? Go to C. C, the first thing it does is, right? Because it called the default constructors, right? And so it called default constructors, you come to C here. And so then you say, oh, C class, I come down to here. Well, not quite yet. And C is derived from B, right? And C is derived from B, and B is over here. And then D is derived from A. And that's where I print out, A equal to 4, right? So you call that, and you call it here, and then you call the, the one with the parameters. Let me see here. And so if it does not give anything, it will not just print out anything. So in A's value, so you print out A is over here, and then B, and because you give the value of that, so you will call, the A as well. So C is this one, right? So first you call this guy here. Let me see here. Not call this one. Okay. So now, the first, because you have two different constructors, and you're also doing the type matching. So because this one is a double, and this is an integer, so you will call this guy, okay? So once you call this guy, right, and the first thing it does, right, and the first thing it does is you call B, and then from B, and so B value, so that's this guy, you will call B. But first, before you call B, you call A, right? So you call A is this, so that's where you get A printed out. Then you get a B. Once you finish it, you come back here, you get the B. And then you're finishing up your own constructors. That is where here, another C, and then you print out this value, right? So this one, this whole thing here is coming from this statement here. And this statement will come from everything from here. And because it's constructor called B, and B constructor called A, and once you finish A, it will come back to B. Once you finish B, it will come back to C, right? So that is the sequence. So now you say, okay, I called the things. Then my next line is a C out of the foo right now. So that's what this guy is. And so out of the things right now, this structure, as I mentioned, is called when the things are out of the scope. Because once you're out of this function, the CC class is out of the scope. So CC class is a class derived from C. I mean, derived from B, B is derived from A. So CC class, in a sense, has a class object of A, B, and C. So now it doing the reverse. It come back and say, oh, I am a C. Okay, let me get rid of myself first. So that's what, this structure is a reverse of constructor. And so you will, excuse me. So you will call itself first. Once it's done that, it's, let me, because C is derived from B, let me get rid of the B now. So you will go to B destructors. Then once you get rid of B, B say, oh, I'm coming from A, since I finished cleaning up myself, let me get rid of the A constructors, right? So a constructor is called the first, the base class first, and continue on. Destructor is a base class is called last, okay? Constructor base class is called first. Destructor base class is called, the last, okay? So now you have an order of constructors and destructors and part of the inheritance. Any questions on the orders on this? Okay. So then let me go through and another example. Let's do this one. Okay, let's do this one, military time. Okay, so I think the book also used that. And there's a lot of example on this. So we defined a time clock, die-edge file, time clock, okay, die-edge. And I have .cpp, so let me just bring up the file itself and okay, so let's see, where is this file at? Let's do a save as. So 24 hours, yep, that's the one, inheritance, okay. Okay, so here is the a time clock, and let me have the time clock as well. Let me bring the base one in. Time clock. Let me just bring everything in, redo it again, just to make sure I have everything. Okay, now I have everything. And so the base class is time, right? Whether it's military time or standard time, is all time. So time has hour, minutes, and seconds, right? So typically that's how we keep track of it. And then you have constructors, set the hours, minutes, and the seconds. And so remember, this is inline declaration. I just made it easier for myself, right? You're not supposed to do this, okay? And then if the same name, you just use this, okay? This hour equal to this hour, minutes, so I just defaulting it. And then I get the hour, I just return the hours, return the minutes, return the seconds. So now I have this die-edge file, and then of course, you all guys know how to use the include guard, right? And so then I say, okay, let's define the the time clock here and military time. So military time, right? It's a military time, and then you include the time die-edge, right? So military time inherits the time, and so you use military hours. For example, when we say 2 p.m., okay, 2 p.m. in the military time is 14 hours, okay? So this way they don't get confused. So mandatory time uses 24 hours instead of 12 hours we typically do. So typically when we say, okay, 3 p.m., we're not gonna say 15 hours, right? Then people say, oh, they have to convert, right? And the same thing. So what you do is for mandatory time, right? And then you have to set the time, get the hours, and remember we also defined the get hours in time as well. But mandatory time is if I stored as 3 p.m., I have to return as 15 hours, right? So you have your own functions. And then here is a function convert the regular time to mandatory time, right? That's all it does, right? And so then you say, okay, how do I implement, mandatory time, right? So that is over here. And so that is your constructors, right? So, and so this way is by default, everything is set to 0, okay? And otherwise, if it's not like that, then you can start doing like this. If, and so you can, if H is less than 10 or H is greater than this, and that means it's invalid hours, right? If it's like this here, right, seconds, you want to make sure that the value they give you is valid. And then you do a convert, right? And so convert pretty much means is how do I convert 14 hours into the correct hours I want, right? And how you convert that. So here is a little functions of converting. And so then other things is once you've done that, right? And so inside your program, right? And so you say time clock, right? And I have this. So this one actually is a different one. So I have a mandatory time, and that's a different test program. So you see this one. Time clock, that's this guy. And so mandatory time, let me see, where is my mandatory time here? I'm gonna find my main program for mandatory time. That's time clock. And time clock. Time clock, where's time clock here? Okay, so time clock also inherits from mandatory time. So remember, mandatory time inherits from time, then time clock inherits from mandatory time. And so this one I will using the different kind of starting hours and end hours. So this way I can show the elapsed time. That's what it is. And to calculate elapsed time, you want to use mandatory time because it's just make it simpler, right? And so that's what this program does. So if I go to time clock, let me see, time test, right? Time clock, then I say, okay, what is the difference between elapsed time between 17 hours to 9 hours? That's 9 a.m. and that's 17, that's 5 p.m. And then you just doing the calculations on that, right? So that is another example of it. And so there is another example I want to show you. And so this one is personal data, right? And so personal data, just like a person, you have a first name, last name, even the address, all this can be taken care of or can be defined in another class. So you can have a class called address. Because address not only pertaining to a person, a business can have an address as well, right? So you can actually separate this two so that you have a person with a first name, last name, and then you have so that what you do is, so let's just do this, right? Quickly just do this one, and so you could, right? You could do this. right? And just call address, right? And so address is only those, right? And then public, then here has, whatever things you want to do, right? And then inside here, right? You can just replace that with the address as well. Just call the, and you can call address, right? And then is, my address. Right? So you can do that. We are learned, right? You can easily do that. So since I have not written the code for that, I don't want to spend the time deal with this, right? So you can do that, right? So now you have all this, right? So here is it's the code, right? You're doing the constructors, right? You define the things, and all the things you want to do, just like everything else, you're defining it, right? And so then other things, what you do is once you've done that, right? And so you can just say, okay, I have another one is customer data, right? So let's say it's a customer data, and I said, well, the customer data, right? It's say I inherits from the public data. Except the customer, I have the customer number and mailing address or mailing list, whether it's on my mailing list or not. So that means you inherit everything from here. So now you can use inside here as well, right? Then you just define the things as you normally do with any kind of class object, right? And and then other things is I also have another one. I can say, okay, I have a preferred customer, and which inherit from customer, right? So customer, which we see earlier, right, is this, and then you have a personal data, right? It's this. So now customer data is inherited from personal data, right? And the preferred customer, right, inherited from customer data. So now you have chain inheritance, and then for preferred customer. Is, well, it depends how much money you spend, how much money, how much money you spend with me. I'm gonna say whether you are my preferred customer or not. I will give you a discount if you are my preferred customer, right? So then I'll come down to here, then I will say here it is, and then I say, okay, how do I determine your discount level, right? Based on how much money, right? And so your discount level, I will determine the level, right? Then I have a function defining that. And that is probably in my CPP file. And determine discount, I say, okay, if you purchase amount, right? So then I know your purchase amount, how much you purchase, right? And how much you purchase, I keep track of that, right? And so based on how much you purchased, I say, okay, if you purchase this level, you get 10%, right? And if you purchase this level, right, you get this, you get this discount, right? A different purchase level, you get a different discount, right? That's what you do, right? And then inside of my main program, I call a preferred customer, right? And then I go set, the customers, right? I set the name, the customers, and for my preferred, and here are all the information I have, and then I start calling them, right? I can print it out, calling them just like anything I want, and calling a member function is the same thing, right? And then you're getting a different. So because the customer also coming from inherited from from this since this personal data, so you can call any functions inside here, okay? And also because a preferred customer also inherited from customer data, and you can call anything inside the customer data as well. So you can call any of those member functions because you inherited, okay? And So then you can just call them, right? And then once you've done that, you can just run the program. So that's compiling it. So this one has many different things already there. And so, I have a make file, which you guys already, familiar with. I did all the things, as you can see, preferred customers, right? And I have a CPP file. I also, so I should also, I did not separate it. I should also separate the things as well into, the different CPP files, right? And as you can see here, right, I have all those things is separated, right? See, customer data, personal data, right? Customer CPP file, I mean the things, right? So I have a customer data, and then I have let's do this one, okay? And preferred customer.h, preferred customer.cpp, right? And preferred, it should have sorted by this, yeah. Preferred customer, personal data.h, right? And so then you just separate the things by itself. And I did not break the things out. I should, okay? That's the reason, right? So all this, okay, you cannot do incline declaration. All this should be a CPP file, right? So once you've done that, right, and when you run the program, right, and so then you can just, let me see here. First, that's this one, and then you can just compile it, right, and then you're running it, right, and right. So now you have everything is ran, right? So that is inheritance, and so for this week, and as I mentioned, next week it's a spring break, and so for this week, your lab is to a person inheritance, and so what it does is, right? So you have a class, a person, then you have instructors, right, which inherits from the person, and then you have a student, which also inherits from the person as well, right? Here is all different kind of requirement, and I'll give you a test code here, and this is your driver program, and you must use this driver program, and then using the same name, right? If I define this as a member function, that's what you do, right? And then here's the output. So this is a very simple program to write. And since next week is a spring break, I thought I'd just give you guys a simple one so you can finishing up this week and then enjoy your spring break next week. Any questions on today's topics? Okay, if not, that's today's session. You guys have a good week. I'm gonna stay on a little bit longer in case you have any questions, okay?